Hi, everyone. In this video, we're going to talk about a rule called L'Hopital's rule, which is great for finding tricky limits. Let's review some limit rules or limit examples that we've done way back when we started the year. So first we have the limit as x approaches -1 of 2x squared minus 2 divided by x plus 1. One of the common limit rules that we used here was, let's see if we can just plug something in. So if I plug in a -1 in for this, I automatically see I have an issue here. If I go ahead and do that, I'm going to get out an answer that is 2 minus 2 on top and a -1 plus 1 on bottom. And I get out 0 over 0. And I don't know what that is. So my next step is to go backwards and see if I can eliminate that denominator. So eliminating that denominator, maybe I can pull out some things to make that work. So let's go ahead and try something else. So let's see if I can pull out an x plus 1. So maybe I pull out a 2. Let's see if I can figure out a way to pull out an x plus 1. And then what would be left over? Well, it would be x minus 1 left over. If I were to distribute that all together, I would get out the fraction over here, or the numerator over there. And then that denominator is still there, and those are going to cancel out. So that's my new limit. So the limit is still there. I'm still approaching -1, but now I can insert it, and I would have 2 times, and now I insert that number. So I insert my -1, but I'm still now minusing 1. And that's going to become -2. So -2 times 2 is -4. So our limit becomes -4. And we did that by finding a function that agreed at everything but one point. Do something similar down here with a limit that approaches infinity. So with a limit that approaches infinity, if we were to plug that in, the numerator would get huge, and the denominator will also get huge. Another issue. So we had an issue that was like this. Now we've encountered an issue like that. Oops. We call these issues right here indeterminate forms because the answer cannot be determined. So they are indeterminate. So we go back in time. We need to eliminate that denominator somehow. One way that we could do this is we could divide everything by the largest power of x. So x squared is the largest power. So if we divide the numerator and denominator by x squared, it will make this a little simpler for us. So we still have our limit as we approach infinity, but now dividing the numerator by x squared, I get out 3 minus 1 over x squared. And in the denominator, I get 2 plus 1 over x squared. Now, when I put infinity in for x, I get out still the number 3 minus 1 over huge is nothing. Same thing down here. I get out 2 plus 1 over huge is nothing. And I get out a limit of 3 over 2. So there was another workaround. There it was eliminating that denominator. Here it's dividing by the highest power of x. In this one, you could do a very similar situation to what we saw up here. You could pull out a factor. E to the x plus 1, e to the x minus 1, and then divide by e to the x minus 1. Reduces, so I have e to the x plus 1. And again, I'm doing the limit of all of this. I never stopped doing the limit. And plug in a 0, and I get, sorry, there's an x there. I get out 1 minus, oops, sorry, that was the plus that was left over. 1 plus 1, which is 2. So we have a couple strategies we've been using to get around this issue of indeterminate forms that we saw up here. L'Hopital's rule does this for us when we can't do this. But first, we need to make sure it's an indeterminate form. because if you could solve it using another way, you really should. An example of that would be if it's a really easy problem. So let me go to another page here. So if we had a really easy limit, like the limit as x approaches 2 of 2x, you really should just plug in that 2 and get out 4. L'Hopital's rule is not going to help you. But what L'Hopital's rule says is if you have the limit as you're approaching some value of a function divided by another function, you should be able to do the derivative of the numerator and the derivative of the denominator, and then take the limit of that new thing. So the limit should be equal to f prime of x over g prime of x. So as long as you're in that form, you should be able to find the limit. And that is what L'Hopital's rule says. Notice how we don't have that fraction form here. L'Hopital's rule can't apply then. So let's look at some examples of this. Let's say you had the limit as x approaches 0 of e to the 2x minus 1 over x. So let's just plug in 0 and see what we get out. We would get out e to the 0 power, which is 1, minus 1, over 0. We would get out the indeterminate form of 0 over 0. So we apply L'Hopital's rule, but I need to check that it's in indeterminate form first. Now, using L'Hopital's rule, I'm going to take the derivative of this numerator and the denominator, and that's the new limit I'm going to apply. So the derivative of the numerator is e to the 2x now times 2 minus 1. That derivative was 0, so it goes away. And now plug in derivative of x is 1. Now we plug in a 0, and we get out e to the 2 times 0 is 1 times 2 divided by 1, and our limit is 2. Again, take the derivative of the numerator and denominator in our limit after you have determined that it's in indeterminate form. If you can do it, just do it. Let's try another. So limit as x approaches infinity of natural log of x over x. If I were to put in infinity in for the numerator, I would get out infinity. And if I were to put infinity for the denominator, I get out infinity. So this is indeterminate. So let's apply L'Hopital's rule. Derivative of the numerator is 1 over x. Derivative of the denominator is 1. This can be written as the limit of 1 over x, as x gets really big. 1 over infinity would be something that's really small, or 0. So that limit would be 0. We would not have any other way of solving that problem, even if we were trying our tricks that we talked about before. Try another one. Limit as x approaches infinity of of x squared over e to the negative x. First plug in infinity, and you got infinity, and e to the really big power is going to be infinity. So now apply L'Hopital's rule, where you take the limit as x goes to infinity of 2x over negative e to the negative x. So again, we're not any simpler here. So we have to apply L'Hopital's rule again. So we're going to take the derivative of what we have. So that would be 2 over, now it's back to e to the negative x. And this is actually like e to the positive x power. And actually, that was incorrect. This indeterminate form would be like infinity and e to the negative x would pop it up here. It's like infinity times infinity. So now as we do this, as e gets really, really big, or to the positive power, a very high one, 2 times infinity would be infinity. So those are just a couple examples of how you could use L'Hopital's rule.